Going on now to the last section of Chapter 2, Lesson 6, Linear Inequalities in Two Variables. Here are the objectives, and I bring your attention to the word and or, which we'll go over in some detail. In math, they have special meanings. And the key to all of this section are these inequality symbols that we see here. Here it's less than, greater than, less than or equal to, greater than or equal to. And the key to all of these is when we go to solve these inequalities, we start off by using an equation for these standard form of the linear equation in two variables. But then, depending upon the signs, if it's equal to as well as greater or less, we're going to use a solid line. If it's only less than or greater than, without the equal, we use a dotted line. Background. Let's go on. So as we look at this, what does this tell us? Well, this was greater than or equal to, because this line separating the solution region is a solid line, and greater than is the shaded area is above. And we'll go over again that detail as we continue our lesson. And here is the protocol. One of the things we often use is what is called a test point to see if this test point is in the region of solution. And you can pause here and go over these. And there is example 1, item A, and it wants us to graph this. Let's go to the whiteboard. Now, to do a little review, since this is in standard form, a good technique would be to find the x and y intercepts. Keeping in mind we're thinking of this inequality sign, but to find the line, we always think of it as equal. So if x is 0, y will be 6. If y is 0, x is 4. So let's make a graph. Plot these points. 0, 6. 1, 2, 3, 4, 5, 6. There's our y-intercept. 1, 2, 3, 4, our x-intercept. And now, what kind of line would we have here? Well, remember, it's only less than. So we're going to choose a dotted line. Now, if it were equal to, also would be a solid line. But now we have to determine where are we going to shade, above the line or below the line. Well, we use a test point here, and our test point will be the origin often. Where will that be? Will that be in the shaded area or not? Well, 0, 0. So if this is 0 and this is 0, is 0 less than 12? Yes. So then this is the shaded point. And it's kind of fun when you use the software, you select the line, whether it's dotted or solid, and then you use a bucket of paint that flows and fills in this area. Let's go back and take a look to see if we had it correct here. And we'll scroll down, and there we do. We have it correct. All right, let's go on to example 2. In item B, I've written the example. Let's go to the whiteboard. Now, in a case like this, we want to solve for y, a positive y. So I'm going to go x, transpose the y to this side, where it becomes a positive y. But we want our y to be on the left, so I'm going to rewrite it y, and the open end of our inequality sign is toward the y, equals x. So, in graphing this, what kind of line would we use? Well, this is also equal to, so we're going to use a solid line. Remember, our slope is 1, goes through the origin, over 1, up 1, over 1, up 1. So our line is like so. Extend it here. Now, we need a test point. But I'm going to also indicate something to you that works. If we have a positive y, and y is greater than something, we're going to shade above. Now let's use a test point, and let's say our test point is here. The ordered pair of that is 0, 2. So y is 2. Is 2 greater or equal to, remember that this was a 0 now? Yes. So this is in the answer region, and all the points along the line because of its being equal. All right, let's go back and take a look at what they will show us for example 2. That was 1, and there is 2. And this works as well. Remember, you can always pause and look at things more carefully. Now in letter C, we have this. X is greater than 3. Well, what kind of line is this? Well, we can just graph it. And we know it's going to be a vertical line going through 3. Now, is it going to be a solid line or a dotted line? Well, because it's only greater than, it's going to be a dotted line. Now, where do we shade? Well, where is x greater than 3? Well, over on the right here. So that's where we shade. And let's check this one out as we scroll down. And there is our answer. Again, you want to be sure you understand the nature of your equation, whether it's going to be a dotted or a solid, and then able to put it in the software. You'll have this practice and then, of course, to certify. Here is background. Again, if it's a positive y is greater, you shade above the line. If a positive y is less than, you shade below the line. And if it's only greater or less, it's a dotted line. If it's also equal to, it's a solid line. And here they give us some background on using graphing calculators. And remember, you can use, if you have one, to check your work, and also desmos.com. Okay, and they're giving us this caution of how to create the border line. Less than or greater than, dotted. But if it's also equal to, solid. Now, when we have two lines and we are checking out as to what's going on, the word and or are involved. And involves intersection, where it's only those that shade both areas, or is everything that would be included. This is union, and this is what they're illustrating here. And deals with sets as well. And I'll illustrate that as we go on to our next few examples. As we go into example 2 now, I'm doing A, and I'll go to the whiteboard. So these were our two equations, or inequalities, I should say. And I want to put this one in slope-intercept form. So I've taken the 5x, brought it to the other side as a negative 5x. And this is critical. I'm going to divide to get a positive y, this side by a negative 2, this side by a negative 2. And again, you may or may not recall that when you have an inequality and you're dividing to solve for a positive value by a negative, to keep this statement true, we must reverse the inequality sign. So this now becomes a positive y is greater than a positive 5/2 x minus 5. So I paused it and set up the graphs a little bit. You pause it and kind of follow along, and you want to sketch these in your notes. So let's plot this one first. Now this is y is greater than this, and it has this y-intercept. So I'm going to put, let's do this one in blue here, blue. I'm going to put a dot here, and then my slope is positive over 2 mentally, and then up 5. So it's going to take me right here. And then now I'm going to use a dotted line here or a solid line. Well, since it's only greater than, I'm going to use a dotted line. Now, of course, when you do this, it's going to make it nice. Now I'm going to go to black and plot this one. Now this says y is less than or equal to x. So there's a 1 there for the slope. The y-intercept is 0. So this is going to be a solid line going through the origin. So again, I'm going to try to sketch this as best I can here. Okay, so I plotted my two lines. Now notice this is an and. And we said was intersection. So here we have to determine where will both of these be true and the shaded areas overlap. Now, what I would do if I had a paper and if I was doing notes and you're doing notes, is I'm saying that this is y is less than or equal to this. I'm going to shade under, because I know y is less. So I go like so. But now, this one says y is greater. So I'm actually going to shade, I'm going to change back to blue to where the blue is above. So my question is now, where do these overlap? And of course, I'm only sketching. And I'm going to do this in yellow here. Hopefully you can see it. It's only going to be in this area here because of the intersection. Now, if this were in union, then all of this would be shaded. But since it's intersection, the word and, it's only the area where both overlap. All right, now let's take a look at what the book is going to show us here. So this is a much more accurate graph, but showing that it's only where the two would overlap is the area of intersection. Okay, we'll take a look at the next one. All right, for example B now, we're going to the whiteboard. And we want to solve this for y. So this would be y is less than, and then transposing the x to a negative 1x plus 4. And this one we know is a vertical line already solved. So let's sketch this one in. And are we using a solid line or a dotted line here? Well, a dotted line. Our y-intercept is at 4. 1, 2, 3, 4. Now our slope is a negative 1. So I'm going to go over 1, up 1, over 1, up 1. And now get a dotted line. And again, this is just a sketch. Now for this one, and I'll change to black. This one is while x is greater than or equal to 4. So we know our y-intercept here is 4, or our x-intercept, I should say. And it's a vertical line. Is it solid or dotted? Solid. So I can just use my line tool here. Now, here, where do we shade? Well, we're going to shade. X is greater, so we're shading over here. And where do we shade here? Well, y is less, so I'll get red for this. And we shade under the line. Now, notice there's some intersection then over in this area, but this is an or, a union. So everything now will be included here. So this is our picture of the graph. And let's check it out. Scroll down, and lo and behold, it almost matches up perfectly. Let me clear it up. And there we go. All right. Now, in this next one, I'm going to go to some background information first. So you can read this over, but write this in your notes. This is going to be critical for this next. Now, the intersection form of inequalities, if we have the absolute value of A is less than A, this is the intersection form. And when we remove the inequality signs, we get x is less than a, and for the intersection, x could have been greater than negative a. In the union form of absolute values, absolute value of x is greater than a, could be written x is greater than a, just remove the inequality signs, or now, indicating union, x is less than negative a. Now, in a graphing situation on a horizontal line, this would look something like that. And on a horizontal line, this would look something like this. So, other words that are not being mentioned here, this is a conjunction and this is a disjunction, but I don't know if we're going to use those words or not. Let's go on. So in example 3, I'm going to use what they've written here. Here are our inequalities. And the first thing we have to do is solve this first one. Again, we take away the absolute value. And then this is an or because of the greater than sign. And write it this way. And we get these two values. I'll give you a moment to write those down. So these are our first two that are an or. Now this next one, because of the inequality sign, is an and. So we take away the inequality signs, just write it. Then write it again, but then reverse the inequality signs and use the negative value, and we get these. So these are our solutions. Algebraically, we have to then plot this into our graph, which is what they're doing for the first ones. Remember, these are x values, and it's an or, and again, it says, showing you disjunction here. This is the blank part between it. So this is shaded, this is shaded. My question to you is, why are we using dotted lines? Well, if you go back, it's only the inequality sign and not the equal. Okay, now plotting the next two down below, we get that these are intersection. So it's only where the two intersect, which are these. And why solid lines? To mark the border. Because it's also equal to. Okay, now what you do is you bring both of these together, and then this is the final answer. So the intersection of all of these is the results that we see here, where things overlap. Okay, this winds us up. And again, if I were to take this step by step, would have really extended this, and we don't want to make it too long. All right, you may be having a test on Chapter 2, depending on the nature of the course you're in.